So here we are for part 3. Here we are for part 3 of our Business Math and Stats Week 2 topic. We've done simple interest, compound interest. Now we're moving into annuities, which is all about regular payments. So let's launch in, do a few questions. It'll just be an overview at this stage. When we get to class, we'll do some of the more complex questions. So we're going to just imagine we'll practice pushing some buttons on the calculator in class as well. I'm just trying to get my mouse to work and it's jumping all over the place. So I do apologize. Let's work out where it's going wrong. Will it let me go back? Okay, thank you. Now there's my mouse. So again, same features, second function alpha 0, 0. With annuities, we're focusing on this payment button here. We'll also be looking at this AMRT button, amortization button, and the scroll buttons here to read what's on the screen. We'll be scrolling around and also using the enter key over here when we come to do the AMRT button. So they're the new buttons. Clearing it, still the same, second function alpha 0, 0. New buttons for today, AMRT over here on the left, just under N, and also the enter button to enter the data, and the scroll buttons to scroll through for our answers. So let's launch in, see what we can do. Okay, what sort of questions does it involve? So, certainly loan repayments, payment of rent, high purchase payments, insurance premiums, all these sorts of things are a superannuation annuities are all examples of annuities. Could be monthly, weekly, semi-annually, annually. So the intervals of the annuities varies. We talked earlier about an ordinary annuity is one where it's paid at the end. Payments are at the end of each period. An annuity due is paid at the beginning. Deferred annuity, there's a little trick to solving those, and a perpetual inventory annuity we'll talk about when we get together in class. So that's that little BGM/END button. We said before, you want to make sure that you've gone, if it's a beginning annuity, second function FV, and BGM will appear up on the screen. But most of the time, second function FV to make it an ending annuity, BGN is clear of the screen. You'll be getting the right answers for a standard loan analysis or other standard annuity question. Okay, so let's see what it looks like. We've got 4 annual payments, $200 each. What does it look like line by line by line if interest is 5% per annum? So we start with nothing, and the annuity doesn't happen until the end of the year. So pretty much we haven't earned any interest because it's an ending annuity at the end of year 1. Pretty much we end up with $200 sitting in the account because at the last day of the year we put $200 in. We're starting year 2 with this balance of $200, and that is going to be in there for the full year at 5%, is earning 10% interest on the $200. And the second payment doesn't hit the account until the end of the year, so we don't earn any interest on that. So the balance then is just the $410. Then 410 is in for the full year, so 5% of 410 will give us the $20.50, and again the 200 is paid in at the end of the third year. And we just keep building the balance up. Interest on the 630 at 5% is that, plus an extra 200 paid right at the end. At the end of our 4 years, we've got $862.03 in the account. So this is where the equations start to get a little bit nastier. And sure, they work if you're but you obviously, if you're in a timed assessment event, an exam, this is going to take you a lot longer than, and trying to find the right formula and then key the data in than just hitting a few buttons. So you maximize your potential of getting better results by using Excel or the financial calculator. So here they are attempting to solve this question with the formula. We actually had to find the growth factor. You could look up the table to find the growth factor as well. But let's do it using the financial calculator. You can play around with these figures later on, but let's have a look at the calculator. So the question is, consider an annuity in which 4 annual payments. Yes, that's the one we saw longhand in the table. And looking at that table, we really want to get that answer of 862.03 at the end. So with our calculator, I might just quickly jump back to, oh, I can't because I'll lose track of where we're up to. It's okay. You're going to have to imagine the buttons with me as I call them out if you want to push these buttons as you're watching the video. So we've got the calculator in front of us. We'll go second function alpha 00. Everything's cleared. This is a payment, so we hit 200 and hit the PMT button. There are 4 annual payments, so 4 is my N, key 4, and then press letter N, or the input N. Compound interest rate 5% per annum. We'll go 5, press the I/Y key. All the data's in, those 3 pieces of data, N, payment, and I/Y. Got those in the calculator. We're ready to compute the future value, so we'll go compute FV, and the answer we get 862.03. So let's just check this out. So the payment, customer deposits $250. So there's my payment amount. Keep looking for a bit more. It's 8% per annum convertible quarterly. So we're going to have to convert it to compounding every 3 months. We're going to have to convert it by going 8 divided by 4 is 2% per quarter. And then we've got to adjust the term to quarters as well. So it's 10 years. How many quarters in 10 years? 10 times 4, 40. Pretty much ready to calculate then that, and we could show it on a spreadsheet. We'll probably do this in class, but we can show that $250. So we'll go second function alpha 00, 250, hit payment, 40, hit N. Don't enter. If you're using formulas, you can use 0.02, but for our calculator, we would just go 2 is my I/Y, 2%. And then compute FV, and we'll get 15,150. Pretty close. There might be a little bit of rounding in that. We'll have a more accurate figure than that if yours doesn't quite agree to that. Well, what's the present value of an annuity? So that was the last couple of questions were have a payment and watch what it grows to, the future value. This one says, hey, what would I need to invest today to be able to receive $5,000 at the end of each year for the next 4 years if it could earn 6% per annum compounded annually? So when it says find the present value, that's what it's really saying. Is it saying, how much would I need to put as a lump sum today that would be the equivalent, which would allow me to withdraw $5,000? So he's done it longhand. We're going to do it. We'll do it on the calculator in a minute. But he said, look, we're going to find the $5,000, the present value of $5,000 at that 6% interest rate for 1 year. And so really it's 4,716. I'm going to find the $5,000 for 2 years, raise it to the power of -2, 5,000 at 3 years, 5,000 at 4 years, and add it all together. For us, with the financial calculator, we'll go second function alpha 00. We'll key $5,000 is my payment, 4 is my N, 6 is my I, so we'd press 6 and then press the I/Y key. We would then possibly just check, did I make any mistakes? Recall payment, make sure 5,000's in. Recall N, make sure it says 4. Recall I/Y, make sure it says 6. Recall FV, you want to make sure it says 0 because you're not trying to find the future value. If there's something in there, you're going to get a wrong answer. So if there was something in future value, you could just go 0 FV and all your data is correct. And then we'll go compute PV. and we'll get $17,000. Now, when we get to class, we'll see if we can prove that that is in fact right, that $17,000 is enough to enable me to withdraw $5,000 at the end of the next 4 years. You could ask, the question might say, well, how much interest did you earn? Well, the idea is, how much did you put in? You put in $17,000, and that enabled you to withdraw $20,000, 4 lots of 5. So the interest would be the difference. So just be aware, don't get lost in the data, be aware of the big picture, just in case a question did ask that and said, well, gee, how much interest have you earned on that annuity? 20,000 minus 17,325. I think I will move on. Let's move on. I think that maybe is that a beginning. Just check. Business owns a contract, 5,000. No, it's the end of each year. It's not a beginning annuity. Oh, it is a little bit. It is a little bit. So we've got to break this question into 2 parts, I believe, is what he's attempting to do. Let's read it. A business owns a contract by which it's going to receive $5,000 at the end of each year for the next 4 years, and this money will earn 6% per annum compounded annually. Find the present value of this annuity at the beginning of the first rent period. That is 1 year before the first payment is made to the business. So really, my understanding of that is, if it's an ending annuity, that is now. We're trying to find the present value now. So there's no real tricks to this. He's still using 4 as his N and 6 as his I and 5,000 as his payment. And we should be able to just go compute. Yeah, so sorry, I thought there might have been a trick to it, but no, this is okay. Okay, Melinda takes out a loan. She wants to buy a home computer. She's going to repay the loan, the monthly repayment. So we know what the payment amount is. We know how long, but then monthly installments, so it's 5 years, 5 12s, so N is 60. Calculate the present value of these repayments. And really what we're trying to say is, if we knew the interest rate was 9%, how much is the value of her loan? What's the loan worth? So yes, you could follow this if you want to do it the hard way. Let's do it the easy way. Second function, alpha 0, 0, to clear out the financial calculator. Key in 120 as my payment, key in 60 as my N, key in 9 as my I/Y, compute PV, the loan amount. The loan amount will always be the PV. So she must have borrowed $5,780 for her repayments to be worth that much, if the interest rate was that, and we're borrowing it over 60 months or 5 years. A family buys a home, they want to put a deposit down right now of 25, and then they want to make monthly repayments, or they do make monthly repayments of $750 over the next 20 years. Interest rate's 9%, compounding monthly. What's the equivalent cash price of the home? Well, the cash price of the home will be the amount of the deposit plus the loan amount. So it'll be the $25,000 plus, we've just got to work out what the value of the loan is. So we'll go second function alpha 0, 0. We'll key in 750 as my payment. It's monthly payment, so it's 20 times 12, 240. And the rate is 9% per annum. So we'll go 9 divided by 12 equals, we'll get 0.75, and we'll press the I/Y key then. 0.75 goes in as I/Y. Once we've got those 3 variables in, compute PV, and the answer you should get on your calculator, 83,358.72. Add the 2 together, and that is the total value of the house, perhaps 108,358.72. Let's say, okay. So this is 2 questions, so it's tricky. They're just Once you've got the basics, we've just got to break it down then into, two parts. So it's really saying an annuity pays 1,000 per annum for 4 years and then 2,000 per annum for 5 years. So it's really, there's two questions for that. The way I'm reading that is that we would need to calculate the present value of this annuity first, and then we'd have to calculate the present value of this annuity, but we don't get that 1 year before the first payment. So we're actually going to have to discount that. Whoops, I hit the wrong button. So this is a tougher question and might be better off if we try and attempt to solve this in class. So at this point, I just want you to get the basics of the annuities. We'll keep the tough ones for our classroom session. Let's move on. So by all means, the textbook's available, and if you want to walk this through before you get to class and have a play with it, that's fine. But right now, let's just move on. A company wishes, so a couple more examples, and that should be enough for us. A company wishes to donate a prize of $2,000 to the top student. They want the prize to be awarded every 6 months at the end of June and December, and they want to make sure it will last for 5 years. The college is able to invest the money, and it receives the interest rate 7% per annum, compounded semi-annually. So let's convert our N. Instead of 5 years for every 6 months, we want it to last for 10 6-month periods. And our rate will be 7% divided by 2. Rate will be 3.5% every 6 months. Once we've got that, we know what our payment is. It's $2,000. So we'll go second function, alpha 0, 0, $2,000, hit payment. 10, 5 times 2, 10 is my N. And 3.5, hit I/Y. Then we're ready. Compute PV. And hopefully we get this answer here, $16,000. Again, we could throw it into a spreadsheet to prove that it'd be enough today if the interest rate was 3.5% every 6 months. We would have enough to be able to withdraw $2,000. And so I'll prove that to you in class. We'll actually write a spreadsheet that will help us prove that we got the right answer. Last thing we'll do today in this video is amortization. It's pretty much, and again, it lends itself well to a spreadsheet. I might have an amortization spreadsheet here. I'm not sure. Yeah, so look here, loan repayment schedule. Just double check. We will look at these Excel spreadsheets, but they're quite good that they lend themselves to showing you line by line by line. In fact, I'll attempt to explain. Yeah, let's just do this. We'll finish on this spreadsheet, and I'll try and talk you through the amortization button on your calculator and how it works. So we'll finish this will do us for today. So what I need 2 things up. I just need a copy of the calculator. That'll do me. Okay, so to make the amortization button work, the very first thing we need to do is calculate the loan amount. So it'll be pretty much the straight sort of, calculate the repayment amount. So we would go second function alpha 0, 0. We would key the amount of the loan and hit PV. We would hit the number of years or months or whatever and hit N. We would hit whatever the interest rate is per month, press I/Y. And then we would go compute payment. Then it will automatically give us the payment. Now we'll see it in Excel in a moment. I'm just walking you through the calculator so you can try this on your calculator in a moment when you can see the spreadsheet in front of you and prove the answers. The next thing, the question might have said, look, hey, what would be the amount of interest charged on the third payment or the fifth payment? Or what would be the balance after 1 year? In which case, we can use this amortization button. It's almost like taking a snapshot, a photo of the loan, if you like. So once we push the amortization button, we just press that, this little thing will come up on the screen. It'll say P1 and P1 equals, and it's really trying to ask, where would you like to start looking in the loan table? Look, most of the time you'd probably say start in period 1. So you might push 1 and then press enter. Doesn't really matter, although sometimes it might say, I'd like to tell what's going on in the 12th payment. So you just want to look at one row of the spreadsheet or the table, the amortization table, if you like. So therefore you would start at row 12 and finish at row 12. But look, at this point, I'm just going to go, I'm going to start at period 1. I'm going to hit 1. And then I press enter and it locks it in. The next step is to press this scroll down key. And then the word on the screen should come up P2. And it's trying to say, where do you want to stop looking? And if the question said, no, I'd like to find the balance at the end of the first year. And if they were monthly payments, that's the 12th payment or the 12th period. So you would enter 12 and then press enter. And then what happens is, to let the amortization button go, or to get it do its thing, we just scroll through. We can keep looping through by using these scroll buttons, and it'll say, okay, when you scroll down once, it'll tell you what the interest is, and then you scroll down once, the next button, it'll tell you how much has come off the principal, and you scroll down one more, and it'll tell you what the closing balance is, or what the balance is. So if you know those buttons, just going over it again, it's amortization, watch for period 1. We need to calculate the loan amount first. Once you've got the loan amount, amortization, it's asking for period 1, or you say, where do you want to start looking? And if you want to start at 1, press 1 and then press enter. And then you have to scroll down and it'll say P2, where would you like to stop looking on the table? And you can say 5 or whatever, wherever you want to stop, and press enter. You must press enter to lock the period in. And once you've locked P1 in and P2 in by pressing enter, you can scroll down and you can see the interest. Scroll down, you'll see what's come off the principal. Scroll down and you'll see the balance. So let's have a look at it, a real life question in Excel. I think this is the one. No, that's not the one I want. This will do. Maybe this is an investment amount. Maybe I want a loan instead. Maybe I want this one. Okay. I've got a pretty big loan here, I think. Let's just check it out. I've got, starting this loan, 1st of March 2020. I'm borrowing $700,000. The rate, a home loan rate at the moment, 2.74%. And the number of years is 30. Now, if it's fortnightly repayments, let's have a look at this calculation here. I'll try and make it a bit bigger for you so you can see it. The Excel formula is equals payment, open bracket, and it's saying, give me what's the rate, and the rate is 2.74 divided by, it's 26 fortnights per year. And then, in fact, if you want to have a look at this window function, this should open up. So really, this tells us, this is where we can actually type our data and it would automatically enter it into the formula for us. So we can tell it where the rate is. We can tell it the number of periods is 30 years, whatever's in E4, times 26. And we can tell it what the loan amount is. Notice I'm putting it in as a negative loan amount, and that's going to make sure that the answer I get is a positive result. If I put a positive PV in, it's going to show me a negative result. Remember, think cash flow in, cash flow out, debits and credits sort of stuff. Once you've got the data in, you'd press done or OK or press on the tick. And it's calculated the repayment to be that. $1,316 every fortnight, roughly, $650 or whatever a week is going to cover this loan. So let's build the loan balance and see how it works. We bring in whatever balance, whatever somebody keys up here is automatically going to come down here because I've said let this value here equal that value there. Press enter. Add the interest calc. So it'll be give me, let this equal, and I'll click on that cell, times, and I'm going to say lock in the rate because I'm about to copy it down. I want to lock the rate in at 2.74 divided by 26. Now notice the interest drops because we start paying the loan off. And then punch in, just make this equal to E5. Again, we've locked it in at $E, $5. So when I go to drag it down, it will always lock in E5. It'll always pick up 1316. Otherwise, it's going to pick up 780 and it's going to be relative. We don't want that. We want it to calculate, drag down exactly that 1316. Same sort of thing here with the closing balance. Let the closing balance equal the opening balance. Add interest, minus repayment. Bang. Let the opening balance for the second month equal whatever the closing balance is at the end of the first month. So let this cell here equal that cell there, hit enter. Once you've done the second row of formulas, once you've dragged that down once and that down once and that down once, all of these formulas keep repeating again and again and again. So we're pretty much ready. Once you've read the second row, we could then drag that down. Now we're going to drag it down for 30 years, but it's 30 years times 26. It's going to go down a long, long way. Not sure, anyway, you'll know how many. It's a long way. Now, if I've done it right, I'll keep going. We're having fun. Scrolling with my, yep, there we go. The 780 periods, 30 times 26 equals 780 and perfect. At the end of the day, we're only paying $9 interest because our balance is so small. You know, it starts to drop and we start to pay a lot off our loan in the last period and we get down to zero. So we know that our calculations are correct. So let's try and mimic what's going on here in Excel by using that amortization button on your calculator. So if you've got the calculator handy, and we'll do this again in class, but you might want to have it handy and I'll just walk you through the buttons. Second function, alpha 0, 0, the loan is always a PV. So TN, 700,000, hit PV. Then let's work out the rate. We'll go 2.74 divide by the rate per fortnight, divide by 26 equals, hit I/Y. Then we'll key in 30 times 26 equals 780, and then we'll hit N. We've got the three main elements in, variables in. We'll go compute payment. And if you've done that correctly, as long as you've got it on an ending annuity, not a beginning annuity, you'll get 1316.70. At that point, if you said, I'd like to have a look at what's going on in the second row, the second payment. So what you could do is you could go, now notice, if you said, what's the balance at the end of the second month or second fortnight, then it doesn't matter what you start at, because you could start at period 1 and end at period 2. But what you will get is you won't get the interest just for period 2. You'll get the interest for period 1 and 2 if you start at 1. If you said, no, I want to know what are the component parts for this snapshot of the loan, period 2, we would then start at 2 and end at 2. So here's the buttons we would push. We'd found the loan amount, we would hit the AMRT button, and it says P1, where do you want to start? We'll press 2 for period 2, then press enter. Then we'll press those scroll down keys, and it'll say, well, where do you want to stop looking? So it'll say, where's P2? And we'll say, well, let's stop looking. We want to look at the end of row 2. So I'm going to hit 2 and press enter. Got that in. Pretty much I can scroll down and it will tell you that the interest was 737.08. You scroll down one more time and it will find the balance, how much has come off the principal. Well, the amount that's coming off the principal is the amount of the repayment minus 737. So whatever 1316 minus 737 is, that's the amount that it will show on your calculator is the amount that's been deducted from your principal. Alternatively, it's this balance minus this balance. And finally, you scroll down one more time and you should see that answer there. So look, practice that. I think that's enough for today. We will leave, we've covered how to calculate a loan payment. We've covered, what else have we done? The amortization button and a few other features. You can have a look at this again. We will walk through some more questions, some tougher questions, but at least you've got the foundations done. So looking forward to catching up with you in person in class. All the best.